region 4, terrain type B, any type of the building, and here steel towers. For steel we usually choose the logarithmic decrement equal to 0.15. Here we need to specify what will be the static wind load for this dynamic case. So we choose when to x. Coordinate of the lower node of the design model under the wind action 0, because we started to build our model from 0. I will tell more in details about this, but later, maybe in the mail. Correction factor. As you see, correction factor is used to correct the, if we need to do this, to correct this dynamic amplification factor. If we want to change the curve, comparing with the curve of SP. Wind of the building across the wind direction. We have 5 meters. Length of the building along the wind direction. We have 6 meters. Okay, this permit you to calculate as much mode as you specify to take into account. Not calculate, Scad will calculate anyway. To take into account as much mode as you specify here. So I don't push this because I want to take into account only modes with the frequency which is less than the limited frequency as per SP. Wind direction along X. Okay, we did this thing. Just to make sure that I chose the right dimensions. 5, yes, and change the basic node. 6, good. The same we do for wind Y direction. Pulsation wind Y. Convert static loads into masses, piezo prop 1, people 0.35. Safe. Okay. Sorry, we need to choose wind for sure, and SP. Then pulsation component 10. Now we went to Y, region 4, type B, any type of the building, steel, wind along Y, correction factor 1, wind of the building across the wind direction. Now I put 6 and along 5. Okay. So now we created a pulsation. We gave all information to calculate the pulsation load case. After this, we go to design combinations and we make inactive static wind but active pulsation wind, because this pulsation load will consist of static part and pulsational part. So it will be, just a moment, exactly this. Okay. Factor of duration 0, gamma f 1.4. Okay. So now we go with the analysis. Do you want to save changes? Yes, I want. The analysis was run, but I want to view the analysis log just a little bit to see what was going on. So accumulating masses. Here program converts static loading into masses for loading 5. This is what we show. Then distributed masses to loading 5, 96 masses. This should be the amount of nodes multiplied by should be degree of freedom. I will check. Then we go how many masses it distributed for x, y and z direction, and the same for load 6. As we specified the same static loads for model for masses consideration, we have the same numbers here. Okay, then calculating dynamic forces for loading 5. Number of modes 10, number of static loading 3. It means that wind 3 was taken for static loading. And then the program says to you, analysis for wind load according to SP. For loading 5, the maximum calculated frequency 3.9 is less than limit 4.3, after which the inertial forces of wind pulsation can be neglected. Is less. It's necessary to increase the number of modes taken into account. So program tells to you that it calculated 10 number of modes and it was not enough to reach the required frequency. Okay, so we need to reduce the calculation, increasing the number of modes. We go design model, go again, design model, loading, correct the existing loads. Pulsation wind X, we increase the number of modes, 20. General data. Pulsation wind Y, increase the number of modes, 20. Okay. Okay. Now we do again the analysis. Task completed. Let's see what we get. So now it gives to us a different notification that for loading 5, calculated modes where the natural frequency is greater than the specified limit are not taken into account. It means that Scad calculated 20 modes, but will take into account only modes with a frequency less than 4.3. So we see that it's 14 modes will be taken into account. And the same for wind X, Y direction. Total external loads. Okay, then some notifications which we can discuss if interested. Then we go to the results. Graphical analysis. Displacement. I choose the total displacement. When here you start to see for the load 5 M, SD and LS plus SD. So M will be modes from mode 1 to mode 14. We can see the deformed shape. Okay, because of the bracing we have this. Our structure is not really participating. And now it started to participate. 13, 14. So this will be just, let's say, deflection. If you want, we can see the displacement from each mode. Then this will be the sum displacement from only pulsational part. So as you know, for the sum we have in the SP we have a square root of squares, some squares. Let's find it. This. But this LS plus SD, it will be amplitude of static and dynamic load. So it will be exactly what we need. The static wind plus the dynamic wind. Also, we can see the force diagrams from this. Okay, moments. So exactly this will go to DSF, to automatic calculated combination, and exactly this, let's say this load case will participate into the calculation, into the analysis. Also here, for example, you can see determine the center of mass. It will show you the coordinates of center of mass. Then you can see the frequencies and periods of oscillations, where you can see frequencies radian per second and in Hertz and the period. Also there is a chart of masses. You can see the percentage of model masses for each and the contribution of each mode in it, X, Y and Z. Here we can see. Okay. So we see that exactly starting from 14. Let's check the value. We had the value, critical value 4.3. Okay.
Più o meno.
So we can see that starting from mode 14, the frequency is greater than 4.3. So that's why Scad didn't take it into account. But also in the end you will have all 20 modes if you want to see the deflection and let's say the shape. Anyway, Scad doing this analysis. Also available accelerations, inertia forces not calculated, weight of model masses. Information is not available for the chosen system of displacement. If we change the displacement and choose one direction, weight of model masses will be available. Okay, and here inertia forces are not calculated. Okay, inertia forces are not calculated. Yes, we can see inertia forces only from each mode. Then you will see the inertia forces and the weight of model masses. Sorry, I will switch off the force diagram. So in general, this is the way how we let's say describe and specify the dynamic wind load in Scad. Again, just to repeat, there is a possibility to specify masses like manually, okay, but we don't do this usually. So we usually use the automatic conversion for model analysis. For the moment, that's all. If you have questions, please call me. Thanks.